Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over our virtual text on linear equations. Our focus will be on how to write linear equations and graph them given a point and a slope. Alright, the instructions are as follows. We are to write the equation of the line with the given slope that goes through the given point. We're going to write the equation of the line in point-slope form and slope-intercept form. Okay? Point-slope and slope-intercept form. Then graph. Alrighty, so let's take a look at the following problem. Let's say we have a line with slope 2 and goes through the point -1, 3. Alright, so let's go ahead and do it. Let's rewrite the pieces of information that we have. We're given the slope, which is 2, and the point that it goes through, which is -1, 3. Now the first thing we're going to do is write down the formula that will guide our problem solving process. Okay, the formula that we're going to use is something known as the point slope form of the equation of a line. So it's given by y minus y1 equals mx minus x1. Okay, if you think about this equation as a recipe, there are 3 ingredients that are needed in order to use this equation to generate the equation of a line. Alright, let's write down the name on the slide. On the side, point slope form. Okay, so the 3 ingredients that we need are namely y1, m, and x1. Okay, so let's see what we are given and see if we need to find anything. We're given a point. This point tells us what x1 and y1 are. Alrighty, so let's write that down. x1 is -1, y1 is 3. Those are 2 out of my 3 ingredients. The last ingredient I need is the slope m, which is provided for us also. So we know that m is equal to 2. Okay, so now what we're going to do is we're going to plug in these values into our point slope equation formula and generate the point slope form of the equation of a line. Alright, so we have y minus y1. y1 is 3. y minus 3 is equal to the slope m, which is 2, times x minus x1. x1 is negative, so we'll put a parenthesis there to prevent us from making mistakes associated with sign multiplication. Alright, let's simplify this quantity in this parenthesis a little bit. So we have y minus 3 equals 2 times x plus 1. Alrighty, ladies and gentlemen, this is one of our answers. This is known as the point slope form of the equation of the line that we're looking for. Okay, so this is the point slope form. The point slope form, as indicated earlier, is y minus y1 equals mx minus x1. So if you have an equation of a line in this format, then you basically have achieved the point slope form of the equation of that line. Alright, now let's go ahead and answer the second part, which is to convert this equation into a slope-intercept form. Okay, so we're going to convert the equation into slope-intercept form. Slope-intercept form. Do you remember what the slope-intercept form is? The slope-intercept form is the y equals mx plus b form. Okay? When you express a linear equation with y explicitly solved for, then you've achieved the slope-intercept form of the equation of that line. Alright, so let's rewrite the point slope form. Y minus 3 equals 2 times x plus 1. Now what do we do first? Whenever you have a parenthesis and a number on the outside, you want to distribute first. Alright, so we're going to distribute that 2 across x and 1. If we carry out the distribution, we get y minus 3 equals 2 times x is 2x. 2 times 1 is 2. Now to get y isolated, we're going to add 3 to both sides of the equation. Alright, remember the slope-intercept form has y isolated. That's why we're executing the steps that we're carrying out in this problem. Alright, so minus 3 plus 3, that adds up to 0. And then on the left side, we have y equals 2. On the right side, 2x plus 5. Ladies and gentlemen, this is the slope-intercept form of the equation of the line that meets the initial conditions given in the problem. Okay, so let's go ahead and specify the name of this form. This is the slope-intercept form. Alright, the slope-intercept form is given by y equals mx plus b. Alright, the last part of the problem is to graph the equation. Now we can graph the equation using the point slope form or the slope-intercept form. Okay, we're going to use the option that's less technical, and that is the slope-intercept form. Alright, so we're going to graph the line using the slope-intercept form, y equals 2x plus 5. Alright, so to graph this line, we need 2 pieces of information, namely the slope and y-intercept. To help us determine what those are, let's write down the slope-intercept formula underneath the equation we are graphing right here. So m, the coefficient of x, is our slope, and then b, the constant that's been added to that term with m, is our y-intercept. Okay, so let's go ahead and write this down. So the slope, which is given by m, is 2. Slope is rise over run, so we need to write this as a fraction so we can know exactly what our run is. Since there's no denominator, the default denominator is going to be 1 because any number divided by 1 is the same number, so we haven't changed the slope yet. Okay, so we can think about the slope as our movement. Okay, as a movement. So think m for slope, m for movement. So that's how you move on the coordinate system. We are moving in what direction? We are going to rise 2 and we're going to run 1. Okay? Those are the movements. Now, where are we going to start moving from? Well, we're going to start moving from the y-intercept. Okay? The y-intercept in this problem is given by the letter b, and b is a constant, which is 5. Okay? B for y-intercept, think about the b as begin. That's where you start graphing from. Okay? So your slope m is your movement, and b, your y-intercept, is where you begin graphing. Alright, let's finish this off by graphing the line. All right, let's start with our y-intercept. That's where you start from. So let me label my axis first. That's my y, that's my x. And then let's see. The y-intercept is 5, so we have 1, 2, 3, 4, 5 right there. All right, so you have that y-intercept graphed, y equals 5. Now, if I want a graph, you notice that my graph could go out of the coordinate system that I am provided with. So rising 2 and running 1 is equivalent to what? In order for me to remain within my coordinate system, I can either rise 2 and run 1, which would take me here, or I can drop 2, 1, 2, and back up 1. It's exactly the same thing. So drop 2, back up 1. You have a set of collinear points that define our line. If you wanted to rise 2 and run 1, you still end up at a point that's collinear to these other points that we have graphed here. Okay, so these are the points that define the line. Let's go ahead and graph the line. Let's make it green. Alright, so this is the line that we are supposed to graph. Now what we're going to do is we're going to specify the name of this graph. Now this graph has two names, and the names depend on the form. Okay, so the first name is y equals 2x plus 5. This is the name of the equation if it's in slope-intercept form. Or you can also call this line y minus 3 equals 2 times x plus 1. That's the point-slope form of the equation of this same line. Alright, how well did you understand the contents of the presentation we just went over? Now to demonstrate mastery, we'd like you to try out the following problems. So try these. Instructions are the same. We're to write the equation of the line in slope-intercept form and point-slope form and graph. Number 1, let's say we have a slope of 2 and it goes through the point -1, -5. Number 2, what if we have a slope of -2 and it goes through the point -3, 1. Number 3, what if we have a slope of -1/2 and it goes through the point 4, 3. Number 4, what if you have a slope of, this one's a little bit challenging, a slope of -1/2 and it goes through the point 1, 2. Alright, so go ahead and pause this video. We'd like you to try out these problems and then we will be displaying the answers momentarily. Alright, so hopefully you had a chance to go through the problems. Let's go ahead and take a look at what the answers are. So for number 1, the point slope form is y minus y1 equals mx minus x1. Okay, and then the slope-intercept form is y equals 2x, y equals 2x minus 3. Okay, so this is a slope-intercept form, and this one is a point-slope form. And then the graph, she's starting from -3, go up, run like that. Rise 2, run 1. Okay, so that's the solution to question number 1. Alright, let's take a look at question 2. For question 2, the point slope form of the equation of that line is given by y minus y1 equals mx minus x1. Okay, and the slope-intercept form is y equals negative 2x. Oh, sorry, this is negative 2 right here. Negative 2x minus 5. Alright, so this is the point slope form. And this is the slope-intercept form for question number 2. The graph 1, 2, 3, 4, 5. Starting from 5, you fall 2 and run 1, or rise 2 and back up 1. Same thing. So the line is as follows. So this line right here is basically the graph of the solution to the equation with the given conditions, going through negative 3, 1, and having a slope of negative 2. Okay, so you can even see the intersection here. That's the point negative 3, 1. That's that we were given originally. Okay, now let's take a look at number 3. Point slope form of the equation of this line is given by y minus y1 equals m x minus x1. The slope-intercept form is y equals negative 1/2 x plus 5. So starting from 5, let's go ahead and graph it. So starting from 5, 1, 2, 3, 4, 5, you're going to drop rise 1, run 2. Okay, rise 1. Rise 1 is equivalent to a fall of 1. Okay, whenever I have a negative slope, you always fall and then run. You do not rise. Alrighty. So that's the equation of the third one. You can see how it goes to the point 1, 2, 3, 4, 1, 2, 3, 0.43 right here. That's indicated in our original problem. You can see how it goes through that given point. Alright, and then last but not the least, we have number 4. The point slope form is given by y minus y1 equals m x minus x1. The slope-intercept form is y equals negative 1/2 x plus 5 over 2. Okay, let's go ahead and graph that. So we have your y-intercept is 2.5 right there. So you're going to rise 1, which is equivalent to a fall 1, and then you run 1, 2. Okay. Alright, let's go ahead and draw the line. So the line going through those 2 points that we have graphed there. Like that. And if you take a look at the line we just graphed, you are going to notice that it goes through the point 1, 2 as specified in the original problem. Okay, so we're looking for it. The original problem states that the line will have a slope of negative 1/2, which we can see here, and it goes through the point 1, 2. 1, 2 is right here, so we can see from the graph that our answer is in fact correct. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of linear functions, equations, and how to graph them, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions, comments, or requests, feel free to post it in the comment section below, and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to other tutorials such as this. More support resources, tools, worksheets, and games can be found at mathgotserved.com, our website. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.